Python, you can do functional programming, so all of your program divided into functions. But in some applications, it might be better to speak of objects. For example, in video games, there might be different objects in the game. So if you were to describe them as functions, it would quickly get very confusing. So depending on the program, you might want to prefer object-oriented programming. So as the name implies, you might have different objects. Each of those objects is created from a single class. So for example, if we have a class, which is basically a factory or a blueprint. So which is a factory? From a factory, of course, you can create different products. In this case, we have the ghost class. So with the ghost class, we can create different objects. And we could do it like this. So we create a new, using the ghost class, you see here class ghost. We create a new object, ghost1, and it has a position, x, y, and a color. So if we were to run this program, you'll see the it equivalents to the location, x and y, and it has a specific color. Now, if we were to create another object, we can simply do it in the same way. So using an x and y coordinates and the color, if we were to run it, you'll see it added another one on that location. And if you were to create another object in the same principle, so using the ghost class again with the properties of the object, and so we have three objects here, ghost 1, 2, and 3. And if I run this, you'll see that we have those three objects just equivalent to the code here. So one important thing to remember is that an object is always created from a class, and there can be multiple classes. For example, we might have another class here, player, with all of its details, but these objects are of the type ghost. They are not of the type player. So they will just look exactly the same. Right? It's like if you have a car factory and a bike factory, the car factory will produce cars and the bike factory bikes. And in the same way here, we have a ghost factory, class ghost, that creates those ghosts. And we have a player factory that doesn't produce anything right now. But we could create one. For example, player 1 is player. That would create a player object using the player class that right now it doesn't have any implementation. So depending, every object is created from a class, but they're not necessarily created from the same class. Now every object has properties. For example, we can change some properties. Let's say ghost1.x and then move it a bit to the side, but maybe not that much. Now if we run it, you'll see the property of that object changed. On line 15, we set it to 600. So that's why it changed. So every object has unique properties. For example, we can set the x position of ghost2 to another position. And you'll see those properties are unique to the object. So ghost2 we set to 300, while ghost1 is set to 600. So every object has its unique properties, even if they are created from the same class. Now you might be wondering what is self here. So it's using self here and self.x, self.y, self.color. So whenever you create an object, it passes itself. So in that self, actually you'll see here there's 3 parameters, and here there are 4, with self included. So self, what Python does, it always passes the object itself, so that it knows what to set those values to. So behind the scenes, this is actually what's happening. And then to itself, this should be 3, and to itself, it's setting those objects. So that's something you can kind of get a better grasp of when you practice with it. But basically it refers to the object calling it. So for ghost1, self would be ghost1. And then it says ghost1.x, ghost1.y, and ghost1.color. For ghost2, itself will be ghost2. And it then sets those values. For ghost3, the same thing, but then for ghost3. So that's just something to keep in mind. Self refers to the object that created it, and it always does that. So for example, if there would be another property, like name, we can add one actually. We can set it to name. Then self, in this case, refers to the first one. I don't know what kind of name, but it can be any name. So those names now are specific to those objects. And it uses self to set them. So here we use self, for example, ghost1, self will set it to red. But for ghost 2, self refers to ghost 2, so it sets it to green. For ghost 3, self refers to ghost 3, so it sets it to blue. So that's object-oriented programming in very brief, the main or the core principles. Let's take a look at this program again. If we run it, you'll see it creates 3 different objects, but all of them are at the same place. They're not moving. So a class can have methods, for example, maybe the move right methods. And let's make that move it to the right. Now, in order to do that, every method here has a hidden parameter, so self. And then we can call the methods on that object. For example, we can say now, we have the method move right in the class ghost. So we can say ghost1 dot move right. That will call the move right methods and it will increase its own variable by 1. So if we run this, if we run this, you'll see it moves to the right very quickly, and because it calls the move right function in the loop. Now you'll see it's quite fast, so if you want, you can reduce the speed. So it moves a lot slower. And we can do this for any, now that you create the method, the move right, you can now do it for any of the objects. For example, let's say we want to move ghost 3, we can then say ghost 3 dot move right. So we're calling the methods on-site the objects. So if we run this, you'll see now both of them are moving, both object 1 and object 3, using the move right method. Now, in this case, we set 0.1, which is kind of a magic number. And you could define a ghost speed. For example, speed is 0.1, and then say plus self.speed. Instead of just randomly plus 0.1, that might look a bit mysterious to other programmers. So now we can say speed. So we have move right. You can do also method, of course, add more than one method. For example, you might have move left in the same way, but now minus the speed. And then we can say, let's move ghost 3 to the left. And then if we then run it, you'll see both of the ghosts are moving. So they're using the methods, so move right and move left. And these methods change the variables of those objects. So for ghost 1, it changes the x object to increase, self.x plus play speed, plus speed. For ghost 3, it moves to the left, so minus the speed. So you'll see that if we run it, one the x is increasing, and for the other, x is decreasing. Now, of course, you can do this for ghost 2 as well. So we can say ghost 2 move right, and it will start to move it as well. You see, now all of them are moving as we define ghost 1, 2, 3. You can change any direction you want. For example, if you want to move all of them to the left. So now all of them would be moving to the left. Doesn't call move left on all of the methods. And likewise, if we change all of them to move right, they're all going to move in the right direction. And they don't all have to move in the same direction. It's completely optional which direction they move in. For example, might want this one moving to the left and the others to the right. And this plane changes the x variable, right? When you go move left or move right, it calls those methods, and it changes x. But this principle applies for any variable. So let's say you want to change the y variable, and we can say move up. And in that case, change the y variable. And you can do the same thing with move down. So now we define two more methods which change the y value, the y variable, instead of the x variable. So if we run this, we can, it will do the same. But if we call the methods on them, so move up and on this down, then this one will change the x variable, and the other two will change the y variable. So if you run it, you see they are now moving in different directions, left, up, and down. And you can change any of those variables with the methods. So even if we, for example, make a method change color, this change color, you'll see there's a color variable. We can change that as well with the methods. So it's self colored, and then self.color is color. So that sets the color for the object itself, change color. So in the same way, we can say ghost1 dot set change color with the name of the color, for example, and let's see. And you see it changed the color of one of them. And of course, you can do that for all of them. So let's make all of them red, for example. If you run this, you'll see those methods that we defined. They all change the parameters of the objects. So moving it left, up, down. And in this case, we use the method change color. So these are all methods that we defined in the class, and they change the object's variables. So for move left here, it changes the variables for ghost1. Move up, it changes for ghost2. Move down, it changed for ghost3. And these change also in the same way. So for ghost1, 2, and 3, we call change color. Now, of course, the parameter can be any you want. So now we change them to red. It can be anything, for example, red. And if you then run it, you'll see all of them are now green. So whenever you have a methods inside, you can use on objects. So here we create some objects. And when we use those methods, it changes the variables of those objects. So we have these objects with specific variables like x coordinates, y coordinates, the color, and the name. And then here we are changing the coordinates of the objects using move left, up, and down methods. And here we are doing it for the color. So using methods, you can change variables for any object. And that's the main idea why there are methods in a class. So we have a bunch of methods here that change the variables. So these are the variables, and these methods that change them. So that is why any objects can have properties. So like these properties, x, y, colors, and name. So these variables, these properties, and then depending on the objects, you might want them to change during the run of the program. So in this case, it's kind of like a game. So you want those properties of the objects to change. All right, we have different ones, and you might want them to change during the game, like the location, what direction they're moving, and so on. So that's why you would want to use methods inside Python for any class. So whenever a method is called, it changes the variables.